Hey everybody, Math 6 5.2. Today we're talking about ratio tables. So to talk about ratio tables, we need to make sure we're good on equivalent ratios, and given the first lesson in this chapter, I think you're probably okay. But let's just make sure we understand equivalent ratios are ratios that, when simplified, end up equaling the same thing. So the ratio of 1 to 2 is an equivalent ratio to 7 to 14. And why is that? Well, we know that 7 to 14, or 7/14, I could divide both the top and the bottom by the greatest common factor of those two numbers, which is 7, and it would end up simplifying down to 1/2, and 1/2 is the same as 1/2. Why? Well, because it's 1 over 2 and this is 1 over 2. So 1/2 and 7/14 are what we call equivalent ratios. Alright, so let's talk about ratio tables. I gave us a partially complete ratio table because we're going to complete that ratio table. And the ratio table here shows us a ratio of dogs to cats, okay? So maybe for every 8 people that own a dog, 2 people own, did I say cats? Birds. For every 8 people that own a dog, 2 people own birds, okay? But then the next value we have in the table is 3 birds. Well, what does that mean for the dogs, though? Well, so let's think about it in terms of equivalent ratio. We know that for every 8 people that own a dog, 2 people own birds. So what would that equal? And again, we're talking about equivalent ratios, right? Ratios are equivalent. What would that equal if instead of the denominator being a 2, it was a 3? Well, 8 over 2, we could think of it like this. 8 over 2 actually simplifies to 4 over 1, okay? So you could say, what do I do to a 1 to make it a 3? Well, 1 times 3 is 3, right? So what's 4 times 3? You could use the dot as well. What's 12, right? So what I would do is go up here and in that spot put a 12. Why? Because the ratio of 8 to 2 is the same as 12 to 3. They both, 8 over 2 simplifies to 4, and 12 over 3 also simplifies to 4 over 1. Okay, so then could we fill in the rest of the table? Yeah, actually we could, because we could say, well, I could put 4 there and say, well, okay, for 4 people who own birds, how many people own dogs? Well, if 2 people who have birds compares to 8 people that have dogs, then what this is double. So that's also going to be double from there to there, and that would be 16, right? I could go 4 and say, okay, oh, I'm sorry, 5, and then say, well, okay, if 2, how do I go from 2 to 5 though? So you can't really do that. So here's another way of looking at ratio tables. We can look at some patterns. So we've got this far, and we could say, you know what, it looks like from there to there to there, I'm adding 1 each time, right? Okay, what's happening up top? From there to there, it looks like I'm adding 4 each time, right? So what's going to go there? Well, what's 16 plus 4? 16 plus 4 is 20. Do it here again, add another 1, so that'd be 6. Add another 4 up there, and that'd be 24. Okay, so what you can tell though again is with all these, every single one of the ratios that come out of this table, 24 to 6, 20 to 5, 16 to 4, 12 to 3, 8 to 2, they actually all simplify down to 4 over 1. All of these are equivalent ratios. Alright, so I want you to pause the video and try this one. Let's just see how you do. Okay, pens to pencils. Alright, so for every 1 pen there's 3 pencils. So what does that mean about this? Well, we could think about the adding pattern, okay? The problem is I can see a pattern here of adding and it's plus 1. But the other problem is I don't know what the pattern there is because it's blank, okay? So sometimes we don't use the adding pattern, or you can if it's available to you, but when there's a gap we can't. So there's another pattern. So we can add different amounts in the top and the bottom. However, if we use a pattern of multiplication, it's the same on the top and the bottom. For example, how do you get from 1 to 2 with multiplication? Well, 1 times 2 gives you 2. So what do I do to the 3 down here? I do the exact same multiplication of times 2. And what do I get? It's 6. Okay, now can I be sure? Yeah, that I was right? Yes, because 1 over 3 and 2 over 6, if I did it right, should be the same. And we know that 2/6 simplifies to 1/3, so this is the correct ratio. And then I could go again, but instead of going here and saying, well, what do I do to 6 to make it 9 as far as multiplication, go back to the beginning. What do you do to 3 to make it 9? Now it's times 3. So take your 1 and multiply it by the same thing as well, a 3. And what's 1 times 3? 3. Now, do we do it right? Well, 3/9 does simplify back to 1/3, so that is correct. So these were the two values you should have had. Alright, so let's do a little word problem here. 36 Cheez-It crackers contain 240 milligrams of sodium, salt. How many milligrams of sodium are in one serving of 15 crackers? Okay, so how would we solve this? Well, we are actually going to use ratios because we know that the more crackers I eat, the more sodium I'm going to take in, and it's going to be constant because every single cracker, individual little cracker, has about the same amount of sodium as every other cracker, right? So there's going to be constant change, so that needs to make us think of ratio tables. So we need to set up a table with the two things that we need to take into consideration here, and I think that would be sodium and its ratio to crackers. Okay, and did they give us any ratio to start out with at least? Well, 36 Cheez-It crackers contain 240 milligrams. Okay, this is a ratio given to us, okay, of sodium. For every 36 someone eats, they get 240 milligrams of sodium. Okay, so 240 up there, and that goes with 36 crackers. But they're asking us how many milligrams, okay, so of sodium. So sodium is what we're going to be looking for in one serving of 15 crackers. So the number of crackers is going to be 15. But I'm going to give myself some space here. Instead of putting 15 right there like that, I need to give myself a little room. So I'm going to put it down here. And of course, this is what we're looking for right there. Now, why did I do that? Well, here's the reason. Sometimes we're just given one ratio, right? We're not given like a table that only has a couple missing things, and we say, oh, that was multiplied by 1, so that's multiplied by 1 here, or that was multiplied by 5, so that's multiplied by 5, or divide by 2, so it's divide by 2. It's not that way. So I think the best method here is to at least try to get our 36 into a 1 if at all possible, okay? But the problem is with that is that I could, do this and say, you know what? If I can multiply on top and bottom, I can also divide, and I can say, well, if I divide 36 by 36, it's 1, and that would be really easy because then I can say, well, that's 1 times 15. Once I get it to 1, then I can multiply it up to 15. The problem is it doesn't work this way. When you do 240 also divided by 36, what you end up getting is 6.6 repeating. And that's not very helpful. So I'm going to erase this real quick. Okay, so instead I think we need to ask the question, can I reduce this? And in reducing it, can I get this bottom number to be something that I could then take and make 15? So let's see. Well, I could divide 36 by 2, and that would give me an 18. But I don't know really how to go right from 18 to 15. So maybe 18, getting it to 18 is not the greatest thing. 36 divided by 6 is 6, but going from that to 6 is easy, but 6 to 15, not so easy, at least not with mental math. So 6 probably isn't the thing. What do you think? Well, I know I can get 36 to be a 3 by dividing it by 12, right? So if I divide by 12, that becomes a 3. And when you take 240 divided by 12, that also works out nicely. Remember, if you're multiplying or dividing, you got to do the same on top and on bottom, and that gets you to a 20. Okay, now this is really easy because I can go from 3 to 15 very simply because I say, well, 3 times 5 is 15, so let's now take the 200. We have to also multiply by 5. Whatever you do to the top, you have to do to the bottom, and all of a sudden we get our answer, and it's what? It's 100, okay? So what's our answer here? Well, how many milligrams of sodium are in one serving of 15 crackers? 100 milligrams. All right, that's all I got for you guys. We'll talk so much more about this in class, but until then, see ya.